Welcome, friends of chemistry. We're doing
What
practice
up, homeboys?
problem and girls number 3. Yeah, well, if they are of undetermined gender, then you have a problem. Figure it out, please. All right, number 3.
3 chemical equilibria are written below, along with their equilibrium constants. Oh, that's a lot of work it saves us. If any of these equations can be written with a single arrow, do so. I'm not gonna. Do you want me to read them all out? Okay, you.
Here,
go
I'll
over
read them out
again.
as I write them down.
Thank you.
Thank you.
Yes, it is.
2 NOCl gas plus O2 gas is in equilibrium with 2 NO2 gas plus Cl2 gas. K equals 2.2 times 10 to the negative 5. Okay. Now notice that this equilibrium constant actually has no units. Okay, what does that tell you? That the molarity in the numerator will be equal to the molarity in the denominator, so that they'll divide each other out.
So
that's why I have no units. Okay, so what are we supposed to be doing with this?
We want to see which one of these can be written with a single arrow. Or if any of them can be written with a single arrow.
How can we know if we can write them with a single arrow or not?
By looking at the well, they're all gaseous, I think, except for this. This could be any substances.
Well, what do you notice about K?
K is.
Okay. What are we talking about here? We're talking about what we learned about. On page 498. On page 498, we see in bold at the bottom of the page, when K is large, the equilibrium is weighted toward the products side. When K is small, the equilibrium is weighted toward the reactants side. And when K is near unity, what does unity mean?
Close to
1.
1, yes.
Near 1.
Mm-hmm.
When K is near unity, the equilibrium is balanced between reactants and products. Okay?
Yeah.
So you don't need to worry here about the units of K. You only need to worry about the value of the digits. Okay? So we're looking at 2.2 times 10 to the negative 5. How close is that to 1?
That's pretty dang close.
Is it 2.2 times 10 to the negative 5?
Oh, sorry, no, it's very small. That's much less than 1.
3.
It's much less than 1, but at the same time, it's only slightly less than 1. Isn't that weird? Mathematics.
So it's actually
crazy.
1, 2. So this is tenths, hundredths, thousandths, 10 thousandths,
so
100
it's very
thousandths.
small.
It's 22 millionths. Okay, 22 millionths. So what do you think? Is that close to 1? Or is it very small?
I mean, if we're talking integers, it's incredibly close, but it's
okay,
very
in
small.
Technical terms, this is very small.
Yes, very small.
So here we have K is very small. So what does it say on 498 about K is very small?
Then it's weighted towards the reactants side.
Okay. So what does it mean to write
that
it?
Means the arrow gets pointed that way.
With a single arrow. So we want the reactants. Okay. So in other words, we kind of write it
backwards,
like this. But that's not conventional. So you're going to rewrite it. You're going to say 2 NO2 gas plus Cl2 gas yields 2 NOCl gas plus O2 gas. Okay? That make sense?
Yeah. Let's have a look at the other one.
Good. As soon as you're done writing, I will erase it. I know you're not looking at it, but I'm just giving anyone who might be
They can pause the video. if they
working
need to
along
do
at
that.
home. All right. Number B. That's a joke. Let's do letter B. Okay, B. Oh, am I reading it again? You'll read it this time? Good.
Yeah, Mom. 2SO3 gas is in equilibrium with 2SO2 gas plus O2 gas, and the K is 1.6 molarities. Is that a big K? I think that sounds like
It
it's
is,
near
it's a big
1
K.
to me.
It is. This is close to unity. Okay?
Okay,
And so that means
it stays the same. It's in equilibrium. The arrow should not be changed.
right. So can we replace the double arrow? The answer is no. We can't weight it heavily towards one or the other side. We're not going to just do the yields thing. We have to keep it like this.
Yes.
It cannot be rewritten.
Yeah.
So, cannot be rewritten. Okay, letter C.
The next one, however, is a different matter. Mystery. 2NO2 is in equilibrium with N2O4, and the K is 9.3 times 10 to the 4, 1 over molarity. So this is obviously a very large K, which means we weight the reaction towards the product side of the equation. So it's going to look like so we're basically just going to change that arrow and write it exactly the same way. Okay, on to 4. Or do you want to pause the video?
We will pause, indeed. Thank you.